Hello everyone, this is Priyanka of Sri Venkateswara College of Engineering, and today I am here to present a presentation on error correction in computer networks. So the contents I am going to cover in this topic are introduction, types of errors, error correction methods, explanation with an example, then finally the conclusion. So let us see the introduction of this topic. Computer networks plays a crucial role in the secured and encrypted transmission of data over the internet. However, the data transfer over a network includes many complex processes that cause some flaws in the data transmission. These flaws are called errors, which can be of different types. Therefore, it is important to correct them for efficient data transmission. The error simply means any flaw or deviation that occurs while the information is transmitted from the source to the destination in a computer network. In other words, if the message or data transmitted by the source is not identical to the one received at the destination, we can say that there is some error in the computer network. In a network, the data or message is transferred in the form of bits that follow a specific sequence. If there is any deviation in the bit sequence, it is called an error. The types of network errors. First is the single bit error. This error occurs when a single bit in the message is flipped during the transmission and the received message at the destination side differs from the original message by a single bit. For example, if a single 1 in the source message is flipped to 0 or a 0 is flipped to 1, we can say that there is a single bit error in the transmission which is shown in the figure. So the bit 0 is flipped to 1 when it is received. So this is the single bit message, single bit error. Next is the multiple bit error. This occurs when there is a deviation in multiple bits of the message during its transfer from source to destination. The bits that are flipped need not be a continuous sequence of bits. Thus, a multiple bit error is found when any non-continuous sequence of bits is flipped in the transmitted message. So here, non-continuous sequence of bits are flipped in the received message where 1 is flipped to 0, 0 is flipped to 1. These are non-continuous. Next is burst error. In this is similar to the multiple bits error with just one difference. The bits that are flipped follow a continuous sequence in their bit representation. This error can occur due to a physical damage to the disk which causes a change in the consecutive bit sequence of the source message. So here the consecutive sequence of bits are flipped when the message is received. Error correction methods. There are two ways to handle the error correction. Whenever an error is discovered, the receiver can have the sender in order to retransmit the entire data unit. This technique is known as the backward error correction technique. This technique is simple and inexpensive in the case of wire transmission like fiber optics. There is no expense in retransmitting the data. In the case of wireless transmission, retransmission costs too much, thus forward error correction technique is used then. The receiver can use an error correcting code that automatically contains certain error. This technique is known as the forward error correction technique. Now let us see the advantages and disadvantages of forward error correction and the backward error correction methods. Advantages of forward error correction are FEC is proactive and can correct errors without the need for feedback from the receiver. It works well for scenarios where retransmission is not feasible or introduces too much latency. Disadvantages: it requires additional bandwidth to transmit the redundant information. The level of error correction is limited by the chosen code. Examples: read Solomon codes, turbo codes. Then backward error correction. Advantages are BEC ensures accurate data transmission by correcting errors through retransmission. It is efficient in scenarios where the Cost of additional redundant information is not justifiable. Then disadvantages are retransmission introduces latency and consumes additional network resources. In situations with high error rate, repeated retransmissions may be necessary, affecting overall throughput. Examples are like automatic repeat request, selective repeat request, check, selective repeat ARQ, checksums, and cyclic redundancy check. Error correction methods. In order to correct the errors, one has to know the exact position of the error. For example, in case if we want to calculate a single bit error, the error correction code then mainly determines which one of the 7 bits is in the error. In order to achieve this, we have to add some additional redundant bits. Suppose R and D indicates the total number of data bits. In order to calculate the redundant bits, the given formula is used. 2R is equal to D plus R plus 1. Error correction is mainly done with the help of the Hamming code. The meaning of the Hamming code, where the Hamming code technique, which is an error detection and error correction technique, was proposed by R.W. Hamming. Whenever a data packet is transmitted over a network, there are possibilities that the data bits may get lost or damaged during the transmission. This can be applied to data units of any length. This code mainly uses the relationship between data and the redundancy bits. Then let us see an example of Hamming code. Let's say you have received a 7-bit Hamming code which is 1011011. The redundant bits are some extra binary bits that are not part of the original data, but they are generated and added to the original data bit. All this is done to ensure that the data bits don't get damaged, and if they do, we can recover them. Now the question arises, how do we determine the number of redundant bits to be added? We use the formula 2r greater than or equal to m plus r plus 1, where r equal to redundant bit and m equal to data bit. From the formula, we can make out that there are 4 data bits and 3 redundant bits referring to the received 7-bit Hamming code. To proceed further, we need to know about parity bit, which is a bit appended to the data bits which ensures that the total number of ones are even or odd. While checking the parity, if the total number of ones are odd, then write the value of parity bit P1 as 1, and if it is even, then the value of parity bit is 0, which means no error. The first step is to identify the bit position of the data, and all bit positions which are powers of 2 are marked as parity bits. Example 1, 2, 4, 8, etc. The following image will help in visualizing the received Hamming code of 7 bits. So you can observe the diagram. First, we need to detect whether there are any errors in the received Hamming code. Step 1. For checking parity bit P1, use check 1 and skip 1 method, which means starting from P1 and then skip P2, take D3, then skip P4, then take D5, and then skip D6 and take D7. This way we will have the following bits. As we can observe, the total number of bits is odd, so we will write the value of parity bit as P1 equal to 1. This means the error is there. Step 2. Check for P2, but while checking for P2, we will use the check 2 and skip 2 methods, which will give us the following data bits. But remember, since we are checking for P2, so we have to start our count from P2. P1 should not be considered. As we can observe the number of ones are even, then we will write the value of P2 equal to 0. This means that there is no error. Step 3. Check for P4. But while checking for P4, we will use the check 4 and skip 4 method, which will give us the following data bits. But remember, since we are checking for P4, so we have started our count from P4. P1 and P2 should not be considered. As we can observe that number of ones is odd, then we will write the value of P4 equal to 1. This means that error is there. So from the above parity analysis, P1 and P4 are not equal to 0. So we can clearly say that the received Hamming code has error. Since we found that the receiving code has an error, so now we must correct them. To correct the error, use the following steps. Now the error word E will be P41, P20, P11. Now we have to determine the decimal value of this error word 101, which is 5 of 22 into 1 plus 21 into 0 plus 20 into 1 equal to 5. We get 5, which is equal to E, which states that the error is in the fifth data bit. To correct it, just invert the fifth data bit, so the correct data will be as shown in the image. Finally, the conclusion of this topic is error correction methods play a crucial role in ensuring the reliable transmission of data across communication networks. The choice of a particular error correction technique depends on factors such as the nature of the communication channel, the error characteristics, and the desired trade-offs between latency, bandwidth efficiency, and reliability. I hope that you understood. So thank you. Bye bye.